right. This here says list all the possible characteristics that sides, angles, and diagonals can have in a quadrilateral. They can be congruent. They can be supplementary. They can be perpendicular. They can be bisected. About it. So, graph paper, here you go. We look all positives, so we're going to go ahead and make it all in the positive. And we'll do 0, 8, 1, 2, 3, 4, 5, 6, 7, 8 for A. And 9, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 2 for B. And CD is 1, 3. Oh, I'm sorry, for C is 1, 3. And D is 9, 3, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So, this is what I have. Find the length of each. Well, obviously, this we just add, right? 15 minus 2, 13. So BD is equal to 13. And then the rest we need some Pythagorean theorems. So, our little calculator out, and Pythagorean theorem it is. Please turn on. Really? I picked out the one guy that isn't going to turn on. All right. I think I picked out the same one. Oh my. Alright, hopefully you got your calculator too in that time, because I finally have mine. Okay, so for this one here, for this side, we've got what, 1 length here, and we have 8. So we have our 8 squared plus our 1 squared, which is what's root 65, which is BC. We have our 1, 2, 3, 4, 5 squared and our 1 squared. So 1 squared and 5 squared is what, 26. So root 26 is AC. And then we have, what, 15 minus 8 is 7. And 9, so 7 squared plus 9 squared, I don't know, 49 plus 81 is 130, so root 130 is AB. Then it says write the equation of AB, which is here. Now, what do we need for the equation of a line? We need the slope, which goes, what, from 8 down to 2, so that's 6. And it goes over a total of 9, which is really, what, 2/3. And it's going through 8 as our y-intercept. And then CD is this guy here. So we have, what, from 1 to 9 is going over, so that's 8. And from 15 to 3 is going down, which is 12. So I reduce that, and that gives me 3 halves. Hold on, we need a negative. This one is my negative slope, this one is my positive slope. And my y-intercept we need to figure out. And so I say I'm going to pick a point. I'll use 1, 3. So 3 is my y, 1 is my x. So I would really do 3 minus 3 halves, which is 3 minus 1.5, which is 1.5. So I would have 1.5 is my y-intercept. So is AB, and this is CD, is AB and CD parallel? No. Slopes are not equal. And are these perpendicular? Yes, because negative 2/3 and 3 halves are negative reciprocals. Okay? So use the algebra to find the coordinates of the point where these guys two intersect. Well, we're finding out where this is equal to this, so we're going to use this is equal to this. And we're just going to do our little math there. So I'm going to move this guy over. So 8 minus 1.5 is 6.5. And 3 halves, which is really what, 1.5, plus 2/3, which is 0.66, is 2.16. And when I do my little division, I get 3. So that is my x value, and that seems about reasonable. That looks about what that is. So then I plug this into either one of these. It doesn't matter. I'm going to put it into this one so it works out nicer. So y is equal to 2/3 times 3 plus 8. So my 3's cancel. Y is equal to 6. Let's see if that's reasonable. 1, 2, 3, 4, 5, 6, totally. So 3, 6 is the point where they intersect. Let's go ahead and look at our next one. We've drawn this, we've labeled this, we are thinking it's a trapezoid. So why would she think it's a trapezoid? Because these look to be parallel. So we're going to provide evidence one way or the other. So if we think they are parallel, we would need to show their slopes. And the slope of this is up 4/7. So SY is 4/7. And the slope of AH is equal to up 3/4. So the answer is no. These are not parallel, so it's not a trapezoid. So that is how we check to see if something is parallel. Does it look like anything else? Well, it might look kind of kite-ish. If these two are equal and these two are equal, that doesn't look like it. So it looks like we're pretty much done with that. Now, even if it doesn't have a special name, it may still have some properties. So use algebra and geometry tools to investigate to see if it has any properties. So find any ones and see. So we could, some of the things that we looked at is we could have perpendicular sides. We could have things that were bisected, things that were congruent. So let's go ahead and check our perpendicular. This kind of looks 90 here. So let's go ahead and see if that is true. This slope, again, we already said was up 3/4. And this slope here is down 4/3, so totally. So AH is perpendicular to AY because the slope of AH is equal to 3/4 and the slope of AY is equal to -4/3. So negative reciprocals. Evidence. There we go. It looked like that was perpendicular. Nothing else really looks perpendicular to me. We know this can't be because they aren't parallel. In terms of equality, this is 5. This kind of looks maybe equal. So I know that this length is 5. So SH is equal to 5. And if I look at AH and use my Pythagorean theorem, I also get 5. So AH is equal to 5, and oddly enough, AY is equal to 5 for the same reason. So those are some things. Again, what do you check? Things that they look like they are. So you use your eyes to see what it might be, and then you use your Mathematica to figure out what it actually is. All right, last one, number 7-101, must be, could be. If a quadrilateral has 4 equal sides, that is the definition of a rhombus. If it is a rhombus, it could be a square given more information. Quadrilateral has 2 pairs of opposite parallel sides. Definition of a parallelogram. So that must be. If it is a parallelogram, it could be any of these things if you knew more information. So rhombus, square, and rectangle. My quadrilateral has 2 consecutive right angles. Well, If you've got those guys being right, the other ones don't have to be, but that, because they're both right angles, makes it parallel, so I'm definitely a trapezoid. I could also be a parallelogram if I had more information, and a rhombus therefore, and a square therefore, and a rectangle therefore. My quadrilateral has two pairs of equal sides. That is a theorem that proves it is a parallelogram. So that's the must be, and if this is the must be, these are the could be's. So rhombus, rectangle, and square.